Hello, and welcome to our presentation on virtual robotics. We're happy to have you here. Cogmation Robotics is a global robotics software developer specializing in STEM-based educational gaming. All around the world, governments, school divisions, and individual educators are realizing that we need to get our students excited about the STEM subjects, namely science, technology, engineering, and mathematics. One proven vehicle that has been used to do this is robots. While robotic programs have a proven track record for increasing enrollment into higher education levels, there are issues. First and foremost, the parts and expertise needed to run a physical robot can be expensive. Secondly, a student's ability to access a real robot can be limiting. Most schools just don't have the money to provide each student with a robot of their own. There are also usually significant travel costs associated with visiting robotics competitions held abroad. But what if we could find a way to get the benefits of using robots as an educational resource while solving many of these problems? Virtualized gamification and simulation is the answer. Simulated robots are much less expensive, meaning that individual students can have continual access to their design. Best of all, the challenges played can be scaled to any age and ability. These next few scenes deal with some of the work we've done with teams participating in the first robotics competition. The designs that you see here were modeled and built by students at a high school in San Diego, California, using our software. While the first robotics competition itself has the laudable goal of promoting an appreciation for science and technology, many schools find it difficult to participate because of the expertise and funding required. Skilled mentors and thousands of dollars for tools and equipment mean that only the privileged few can have the experience of discovering what's possible with a little bit of ingenuity and effort. How awesome would it be if students everywhere could have this same opportunity? In the next few minutes, I will briefly demonstrate just how easy it is to get started with a virtual robot of your own. We start off in Robot Builder. You might think of Robot Builder as being a virtual drafting tool for robotic applications, or simply put, it's a virtual garage where we can start to assemble our robot using some pre-built assemblies. To get started here, I'll just create a new project, and the first thing you'll notice is that Robot Builder contains a lot of the popular features we'd find in other programs in terms of allowing me to customize my workspace. So I'm going to set up my environment in a configuration that I like best. And I have one more window I need to add. Great, I'm all set up. This is actually the first page of the Pitsco Tetrix instruction manual. What we'll notice right away is that the parts in the manual can also be found within Robot Builder. Just going to take a moment and scroll up here to the top. We'll notice that within Robot Builder there's a virtual toolbox containing a complete inventory of Pitsco and Lego parts. Here I can find the first couple of parts I need to start assembling my robot: a 144mm angle, a 288mm channel, and the two connecting screws, which should be down here. Yep, there they are. But I'm going to start first by actually creating a work surface. I'll take one of my primitive shapes here and I'm just going to drag it out onto my 3D grid. Building a Robot Builder is really just that easy, finding the desired part and dragging it out onto your work surface. With my work surface established, I can now begin the process of finding the parts that I need and pulling them out into my 3D environment. Again, I'll go to the top here, I'll find my 144mm angle, and I'll drag it out into my workspace. We'll notice that almost instantly the part shows up. If I scroll down, I can find the opposing beam that I'll need, which is this 288mm channel. Channel is quite a bit bigger than the angle. And once I have these two parts, I can begin the process of customizing the parts. You can see here that between dragging and dropping and changing properties in the different windows, I can quickly and efficiently start to design my robot. This is a time-lapsed build of the remaining steps in building the Pitsco Tetrix robot. And you'll see here that over time, we can actually build quite a complex robot. There's really no limit to how in-depth you can go with detailing. You can pretty much model this robot right down to the level of the individual screw. Here we can see the process of connecting individual Lego pieces to the NXT brick. With my sub-assemblies in place, I now just take my NXT brick and I drag and drop it onto the Pitsco Tetrix chassis. And that's that. My 3D robot is now ready to be played with in a virtual environment.